Hello everyone. In this project, we use PCA and K-means to cluster the customers with the first introductions. So assume we are one producing company in our project. We want to use K-means and PCA to cluster our customers according to several features, including the age of our customers, the number of kids our customer have, the number of teens in our customer's family, how long has been our customer enrolled in our firm, and the number of days since our customers last purchased. And we select our data set from table. So here you can see the 5 dimensions we have selected for our project. Okay, so the problem we want to address is how can we make our advertisement more targeted and effective? And why is it important? Because we want to advertise to customers who have the highest willingness to buy our product. Therefore, we can make the most profit from the least amount of resources. Okay, so the central aim of our project is to cluster our customers into 3 groups and send out the corresponding advertisements to the specific group. Okay, so the related works. So all these 3 papers illustrated the common process of applying K-means for customers, and also they all determine K by using different methods, running K-means and get several clusters, and label the cluster and observed pattern of each cluster.
Now let's see the method part of our project. We will introduce in 3 steps: flowchart, description of the process, and algorithms we use. First, with the flowchart, I hope you will understand the process better. We have 2 comparative groups, and one is done without PCA, one with PCA. They both have the similar process, like cleaning data, determining the value of K, running the K-mean algorithm, and analyzing the result with 2 measures. Among the flowchart, there are 2 critical control groups that you should already know. The first one is with PCA versus without PCA. The data set is 5D, so we could not visualize it. In this case, determining the K would be difficult since objective tests such as elbow may not show an obvious result of consistency. And subjective test doesn't work since we cannot directly observe the data. Hence, besides directly clustering, we apply PCA to decrease the dimensions in the other control group and see which is better. Second control group is the minimal expense on Y products over income versus the expense on Y products over expense on other products such as fruit and meat. In order to show the willingness to purchase of each class, after unsupervised clustering, we designed 2 measures to compute the willingness and see which is better. Now, let's introduce the algorithms we use. In this project, we mainly use 2 algorithms that are taught in class, K-mean and PCA. We use K-mean to cluster the customers into separate categories by selective features. And there are 2 potential problems with K-means. First, we should determine the appropriate value of K. Second, we should choose the appropriate dimensions. By using PCA, we can reduce the dimension of our dataset, excluding the least important. The problem would be how many dimensions that we should reduce to.
So the next part is about the process of the data. And the first step is to do the data cleaning. We first import the Excel into the Jupyter notebook, and we'll use the pandas to do the data cleaning. So the step 1 is to find the null value. And we find that only the income column contains the null value. And the null value is less than 2%. Since our goal is not to investigate the missing type, we'll just drop this missing value. And then we're going to do the standardization to all the numerical variables. Since we're using the K-means, we need to compute the square difference in the K-means algorithm. If the units of the variables are different, we can't use the square difference appropriately. If we don't do the standardization, some variables may have higher impact in the square difference compared with other smaller value of variables that will distort our K-means algorithm. Then in our next part, we're going to do the one-hot encoding to convert the categorical variables to the dummy variables like 1 and 0. then we wrote our k-means by hand. And in the method run k-means, we input a data frame and the number of cluster we wish to achieve and the maximum iterations we need to do. And then it will produce a new data frame with a column of the cluster. And then we're going to investigate how do we determine the K. And we use 5 methods. The first is the How-to method. We find the global maximum in this plot and find that the optimal K is K equals to 5. And then in the elbow plot, we find the elbow is at K equals to 2. And then in the other 2 methods like AIC and BIC, we find the optimal K is very large, which is not suits our interest. And then we compare the performance of K equals to 2 and K equals to 5. We find that K equals to 2 produce better results in the k-means clustering. So that's all for my part.
Thanks, Bison, for presenting the process of data cleaning choosing optimal K for k-mean algorithm. I will present the result of k-mean with 2 clusters and analyze the characteristics of each cluster. First, we summarize the mean of 2 metrics respectively. We found that the means of the metrics are consistent for each cluster. People with label 0 are likely to spend more proportion of money on wines, and people with label 1 are likely to spend less proportion of money on wines. We then calculate the proportion of people's relationship status for each cluster. We found that the cluster 0 has a higher proportion of widow and divorced compared with cluster 1, while the cluster 1 has a higher proportion of single compared with cluster 0. Both clusters have similar proportion of together in married people. Similarly, we looked at the proportion of people's diplomas for each cluster. We found that the proportion of PhD master is higher in cluster 0, while the proportion of graduation and cycle is higher in cluster 1. We then calculate the average age, recency, and income for each cluster. We found that people who tend to have high willingness to spend money has a higher age and income on average. Since cluster 0 has much more people compared with cluster 1, the proportion among cluster cannot really help to find the new customer's cluster given his or her characteristics. We also calculate the proportion of belonging different clusters for each relationship status. After calculating, we found that 92% of widow is in cluster 0, meaning that if our new customer is a widow, his or her willingness to purchase wines is high. Similarly, we found that PhD average has a higher willingness to buy wines. People with 1 teenager is more likely to purchase wines. Besides of looking at the characteristics of new customers, we could also use metric amount spent on wines over amount spent on products to predict the cluster of customer numerically, because this metric has a larger range, which is more distinguishable between 2 clusters.
So our first step is to reduce the dimensionality of a dataset. First of all, we choose to visualize the dataset from the graph here. We can see that the optimal K should be 2 or 3. And we run the k-means and print out its variance ratio. From the variance ratio, we can see that the first 4 columns have the largest variance, so we should preserve them. And we run the PCA and get a result. So before we run the k-means, we will use the elbow graph and the circle score to determine the optimal K value. And it turns out that the elbow graph didn't work very well, so we will choose to use the circle score, and the optimal K value is 3. And we run the k-means and we visualize it, and turns out that the outcome is pretty good. And you can take a look at the statistic. So from the data above, we can see that cluster 0 represent the low willingness customers, and the cluster 1 represent the middle, and the cluster 2 represent the high. So by looking at the statistic, we can see some patterns. So for the customers with low willingness, they usually have the elder age around 52, and most of of them do not have kids. But for the customer with high willingness, they usually have a younger age, around the age of 40, and most of them do have kids. Another pattern we can see that compared with the customers with high willingness, customers with low willingness usually have a small enrollment age and a long recency, which indicates that they are new customers and their shopping frequency is pretty low. Comparing two measures, we can see the second measure works better because it has larger differences between the clusters. Comparing the result from without PCA and with PCA, we can see that some of the patterns are different. So for the without PCA, customers with the high willingness usually have a larger age, but for the with PCA, customers with high willingness have a younger age. So some of the patterns are similar, some of are different. We believe that this is because PCA excludes some dimensions which influence the outcome of clustering. So maybe it's not a good idea to use the PCA before k-means.
So in the discussion section, I will briefly talk about what we have learned. First, the whole process and the difficulty we may have of k-means algorithm. And second is the problem may exist in unsupervised learning. And the third is a lesson from PCA. Okay, so first we should properly select the data, and we know from this project that the binary variable 0 and 1 cannot be taken into the k-means algorithm. After that, we should determine the proper k. And we may have difficulties in this part because the L bottle in the class may not always work. And second, one thing we learned from this project is that most of the time, unsupervised learning algorithms don't classify the data into clusters that we are familiar with. It is our job to have to look carefully into each cluster to find the underlying pattern the algorithm has found out. And third, PCA doesn't work very well because it always excludes several dimensions and rotates the data set to reduce the dimension. But PCA proved to be very helpful in visualizing high-dimensional data. As we see in the previous slide, PCA allows us to visualize the clustering result of k-means, which is clear and easy to comprehend. And fourth, in this project, we use elbow, sickle, AIC, and BIC respectively to find the optimal k. Though there are different methods, each method indicates different optimal k. So we need to try each method and find which optimal k is truly optimal for our dataset.
Even though we finished the project, there is still something we could do better in the future. First, in this project, we only use two measures to represent the customer's willingness to purchase our wine. But if we are given more time, we will come up with more measures to make up the project less biased and more convincing. Second, we use one hot coding to encode the categorical data, which cannot be accepted by k-mean algorithm. After research, we found that an algorithm called k-mode may help. Maybe we will do it in the future. Third, another improvement we could do is supervised learning. Because classification by unsupervised learning may not always classify the data in the way we expect. Hence, one more we can do is to split our dataset into training part and testing part and make our classification more convincing. Finally, in the future, we may try different combinations of dimensions and make the customer segment more accurate. And that's all for our project. Thank you for watching. Hope you have a good day.